Hey guys, good morning. So I actually created a flow map for you guys to help, and then I'm going to do an example so we can have like a parallel flow map with the steps on how to use substitution and then an example. So I'm actually on IXL right now. I know that your guys' task was only get up to 50, but I challenge you guys to try and get further just because you guys are heading into high school where you'll probably see things like this. So the more you understand it now, the better you'll do in high school. So step one is pick an equation that has a variable isolated as the substitute. If neither of the equations has a variable isolated, solve one, and I'm going to actually edit that. Solve one of the equations for one variable. So as we see here in this example that I wrote down, I have 6x plus 6y equals 6. And then the second equation is negative x plus y equals negative 7. Neither of these two equations has the variable isolated, which means by itself on one side. But if you look at the second equation, what we can do is we can actually isolate the y, because if you notice, it has a negative x right there. So what I'm going to go ahead and do is I'm going to work that out right here. So we have 6x plus 6y equals 6, negative x plus y equals negative 7. And like I said, if we look at the second equation, you guys can see that if I get rid of this negative x on the left side, then we'll have the y by itself. So in order to do that, I need to do the opposite, which is add x. And what you do to one side, you do to the other. Now, as you guys can tell, on this side, these negative x plus x, they'll cancel out, and then I need to bring down the y. So then this is going to be y equals. Now on the right side, you cannot combine the negative 7 plus x because those are not like terms. Negative 7 is a constant and x is a variable. So I'm just going to bring them both down. So I'm going to bring down the positive x first and then the negative 7 like that. So now I have changed this equation to be y equals x minus 7. So I'm going to actually kind of just write that down. I'm going to use like a little arrow. I wish it would be an arrow. There we go. Y equals x minus 7. Okay, so I changed that second equation to be y equals x minus 7. And now I am going to pick that second equation as the substitute. So what this means, since y is isolated, it is going to get substituted. It's going to get replaced. And what it equals, which is this x minus 7, that's actually going to be your substitute. And it's going to be the substitute for y. I like to use a comparison with even when you get a substitute for a teacher. Let's say that y is myself and I am going to get a substitute. What the substitute does is it obviously goes into my classroom and takes my place. So I am no longer going to be there. So what that means is when I go to this other equation, so substitute the variable in the other equation. So I was using the second equation. Now I'm going to go use the first equation. And that first equation was 6x plus 6y equals 6. What's going to happen is the y right here is going to get replaced. And just to kind of help you guys notice that, I'm going to, is this a highlighter? No. Here we go. I should use yellow. So what this is going to do is this substitute, x minus 7, is going to go in to the equation and replace it. Now 6y means 6 times y, so it's actually going to be 6 times x minus 7 and then equals 6. So everything inside of the equation has remained the same except for the y. So hopefully you guys can see that there. Now I'm going to do the math with you guys down here. So now what ends up happening is step 3. Now you should have an equation with one variable, and I should put with only one variable. In this case, my equation that I have with only one variable is this one, 6x plus 6 parentheses y, or 6 parentheses x minus 7 equals 6. Now this equation, since I replaced the y, now there's only x's, which means that I can now solve for x. So I'm going to go ahead and just change the color. So 6x plus 6 parentheses x minus 7 equals 6. That's what I mean. So we're going to do the steps to, I'm going to go ahead and erase this. Please remember, you guys can pause, you guys can rewind, so you guys can go back and see the work, take notes. And actually, I'm going to go ahead and do that right here on step 3. Now I've changed that first equation so that it is 6x plus 6 parentheses x minus 7 equals 6. So that's what I mean. You only have an equation with one variable, and this one variable in this case is x. So that means that I can now solve for x. And to solve for x, we're actually going to have to do the math, the steps that we have on page 14 of our binder. Those are the steps to solve an equation with one variable. So since now I have an equation with only x, I could actually use those steps. So step 1, I'm going to go ahead and use blue. Step 1 is distribute if there are parentheses. So obviously we see the parentheses there, and the parentheses means to multiply. So this 6x, it's away from the 6 parentheses x minus 7, so we leave that alone. But now this 6 times x makes another 6x, and then we have a minus, and then 6 times 7 is 42, and then everything else stays the same. So the only thing that changed was this right here because we distributed. And now step 2 is to simplify both sides of the equation by combining like terms. And if you guys notice on the left side, we do have like terms. We have the 6x and the 6x. We can combine those because they are on the same side. So I'm going to go ahead and combine these two. 6x plus 6x makes 12x minus 42 equals 6. And then step 3, it's to isolate the variable to one side of the equation, but we already have the variable on one side. We don't have another x over here on the right side, so we skip step 3. And now step 4 is to add or subtract the constant that's on the same side as the variable by doing the opposite. So this is the constant that's on the same side as the variable, so I'm going to go ahead and add 42 to both sides. And then we bring down this 12x, negative 42 plus 42, they cancel out, and 6 plus 42 is 48. And final step, step 5, is to multiply or divide the number with the variable by doing the opposite. So the number with the variable is 12, and since they're together, they're being multiplied. So I have to do the opposite, which is to divide by 12 to both sides. 12 divided by 12 makes a 1x, so we could just say x equals, and then 48 divided by 12 is 4. So that is actually step 3. Sometimes you're going to be required to do a lot more work, as we saw here. And that's because these get a little bit more complicated as you progress, because now they're trying to challenge you. And this is actually how your systems of equations will look like next year in high school for Algebra 1. So now I'm going to go ahead and just go in here and say that I'm not going to have you guys type it out. Shout out to everybody that did type out their work. That must have been very challenging. So you know what? No, I'm going to go ahead and type it out. Remember, we distributed, and then we combine like terms. 12x, 6x plus 6x is 12x, and then we saw the minus 42 equals 6. I don't know how some of you guys did. I think you guys would do this, and then you add 42 to both sides. And then we get 12x equals 48. And some of you guys, I don't know how you did it. You said to divide by 12 to both sides. I'm just going to put that on the side. And I'll just make that smaller so that it all fits right there. And we get x equals 4. So now, since I have solved for x, I still have to find out what y is. So I'm going to go ahead and erase all that. So now That's step 4. Use that answer, this x equals 4, to solve for the other variable. So now since I know that x is 4, I'm going to go ahead and plug it in to the original equations. The original equation were these two. So I'm going to use this one just because it has a lot less stuff going on. Because here we have 6 times x plus 6 times y equals 6. Here we would just have negative x plus y. This is a lot simpler to work with. So I'm going to go ahead and choose the second equation to solve for the other variable. Now actually go ahead and do the work there. Please make sure you always go back to the original ones. I know we did change these, but sometimes you can make mistake even when you're changing them. So it's best to always go back and use the original one. So I'm going to go ahead and type in negative x, because that's the equation I'm going to use, plus y equals negative 7. And since I know that x is x is 4, then I'm going to plug in 4 for x. Now there is a negative in the front, so it's going to become negative. And then x is 4, so now it's negative 4. Plus y equals negative 7. Next step would be to add 4 to both sides. So I'll go ahead and kind of use the pen here. So what I'm going to do is I'm going to add 4 to both sides, but I'm going to type it all out. Okay, what I'm doing right now is I'm going to add 4 to both sides. Then these will cancel, and I'll bring down y equals, and then negative 7 plus 4 is negative 3. So now I will type it out. And I am going to add 4 to both sides. So over here and then over here. So then those negative 4 plus 4 cancels out. So I'll go ahead and put y equals negative 3. I should have wrote a step 6, and I'm going to explain to you guys why. The reason I say to do a step 6 is because we also need to check our answers. So it says write your answer as a point x comma y. So since x is 4, y is negative 3, we would write it as a point. But one thing is you guys have to make sure that you guys check your answers. So I'm going to actually go back to the decimals, or sorry, IXL, but I'll go ahead and do that here and then go back to this. So x comma y, we're not going to write that out, but we're going to write it out with our numbers. X is 4 and y is negative 3. What I mean is check your answers, you guys, because these get more complicated and I don't want you guys to get it wrong just because you didn't double check it. So I'm going to go ahead and use, let's say, purplish for the first equation. So we have 6x plus 6y equals 6. We're going to plug in 4 for x and negative 3 for y. So now this is going to become 6 times 4 plus 6 times negative 3 equals 6. 6 times 4 is 24 plus 6 times negative 3 is negative 18. And then you can use a calculator, or if you remember your 7th grade rules, these are different signs. So we subtract 24 minus 18 is 6, and we keep the sign of the larger number, which is positive. So it's just positive 6 equals positive 6. So it balances out the first equation. For the second equation, I'll go ahead and use an orangish color. So the second equation, let me erase that. I was trying to underline it with my mouse. Didn't work. So the second equation is negative x plus y equals negative 7. So once again, I'm going to plug in 4 for x and negative 3 for y. So this is going to be negative, and then x is 4 plus y is negative 3 equals negative 7. And what I'm doing again is just checking that it balances out both equations. So negative 4 plus negative 3 is negative 7. And then we can see that it also balances out the second equation. So when x is 4 and y is negative 3, it balances out both of my equations. For the first equation, it balances out to 6 equals 6. And then the second equation, it balances out to negative 7 equals negative 7. So because I double checked to make sure that it did balance out both equations, now I know for sure that the correct answer is 4 comma negative 3. All right, so once again, this was my original system. And then I needed to pick an equation that has a variable isolated as a substitute. The original system of equations did not have a variable that was isolated, so I had to do this second sentence. If neither of the equations has a variable isolated, solve one of the equations for one variable. So I added x to both sides so that I could get the y by itself on the left side. So y equals x minus 7. Then if you guys remember, since y equals all of this, x minus 7, then the x minus 7 is going to be my substitute for y. So substitute that variable in the other equation. So I substituted y into the other equation, which was the first one. Now you should have an equation with only one variable, so solve for that variable. So once I replaced y, now I only had an equation with x. So then I had to do a little bit of the math on page 14 and list the steps so I could solve for that variable. So x is 4. Then I have to use that answer for the other variable. So since x was 4, I replaced it. And you could have picked either one. I just chose to pick the second one just because it was a lot simpler. So I used the second equation, negative x plus y equals negative 7. And then I replaced x with 4 and then just did some simple math to get that y is negative 3. So please make sure to also check your answer. So of course, I want to go ahead and do a step 6 because I'm a teacher like that. And usually on a flow map, you do always go from left to right. It's like reading. So that's why I'm kind of doing this. Step 6, which a lot of you guys skip. Check your answer by replacing the answer into both equations. Make sure they both balance out. I want to put a smiley face because I know you guys love doing that last step. And I will go ahead and add a border color so it is visible there. And now I'll go ahead and scoop this down. All right. I'll go ahead and share this document as well once most of you guys submit it. But if not, pause the video. For the flow map, I don't expect you guys to do an example. I just did that to hopefully help you guys out a little bit more.